Hey guys, so in the last video, we talked about the periodic table square, which is what you can see here to the left. We have the element symbol, the atomic number, the atomic mass. Hopefully you watched that video. If not, go ahead and watch that one, and then this one will make more sense. So this video, we're going to focus on the isotopic symbol. And the periodic table square is obviously very helpful. It can tell us a lot of information, but sometimes that information changes, or sometimes we need it to be more specific. And that's where the isotopic symbol comes in. So you'll notice a couple differences. The main one being that the atomic number, which is normally in the top right on the periodic table, is now down here on the bottom left. I know that seems weird, but it makes things easier once we get to, what we're talking about here. So again, just a reminder, this is the atomic number, and it's the number of protons. All right, and then at the top here, this number, you'll notice it's a little bit different from this number right here. I'm not gonna highlight that because it's not the exact same, but I'm gonna underline it because this number, instead of being the atomic mass, is now the mass number. Notice that it's a whole number. I don't know what the heck my pen is doing. Mass number, it's a whole number because it represents the protons plus the neutrons. And so I can look at this and I know that if my atomic number is 9, so I have 9 protons right here, right? I can say that I must have 10 neutrons because 9, let me maybe make that 9 plus, whatever equals 19. Oh, whoops. Oh, sorry. There we go. 9 plus whatever has to equal 19 because it's the protons plus the neutrons, which is what I don't know, equals 19. That's the mass number. Then I have to have 10, of course, because 10 plus 9 is 19. So I have 10 neutrons. So that's really helpful. Otherwise, we just be, guessing, is it the typical isotope or is it another isotope? We don't know. So the isotopic symbol tells us which isotope we're looking at, what the mass number is, and how many neutrons there are. So we can easily figure that out. And remember I said this is down here for a reason? Well, it looks like a math problem. When you subtract, you got a big number up top and a small number on the bottom. 19 minus 9 is 10. I don't know. I just like the way that looks. So that helps me remember what I'm doing. It's like a math problem. And then finally, this little guy right here. So this number at the top, I'm just going to swing over here for these notes. This number represents the charge. And a charge means it has a positive or negative charge. It's no longer neutral. Over here, if we look at the periodic table square, I know that this fluorine has 9 protons, right? And if it has 9 protons, well, then it must have how many electrons? 9. It has to have 9. So in a neutral atom, the number of protons equals the number of electrons, which makes sense because electrons are negative, protons are positive, and in order to be neutral, they have to be equal, right? So fluorine has 9 electrons all the time, no matter what, as it sits on the periodic table, unless it is bonding with something or an ion or, whatever, however, we haven't really talked about the situations in which this will happen yet, but in the isotopic symbol, it tells you if it has a charge or not. If this space up here is blank, then you assume it's neutral. It has 9 electrons, 9 protons, and you're done. If you see a number up here, whether it be a positive or a negative anything, that means that you have a charged atom. And the only way to get a charge is to lose something. So let's think about this here. We have protons, which are positive. We have neutrons, which are neutral. And we have electrons, which are negative. So you should be thinking to yourself, okay, what can I lose in order to get a charge? Well, if we lose neutrons, let's say we, plus or minus neutrons, is that going to affect the charge? Hopefully your answer is no, because neutrons are neutral, and so they have literally no effect. So when we change neutrons, all that does is it changes the isotope. We have a new isotope. Then we look at the protons. If we change the number of protons, will that affect the charge? Hopefully your brain is confused and torn, because yes, it would affect the charge, obviously. However, we have said many, 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 many times that protons can't change. We cannot change the number of protons. It's not possible. Don't do it. Don't even think about it. And that leaves us with electrons. So a charge happens when an atom loses or gains an electron. So here's the hard part, and I say hard, but I really mean easy, but I also mean hard, because you kind of have to use your brain a little bit. It's easy math, and when you make the mistake, as soon as I point it out, you're gonna be like, oh my gosh, I'm so dumb, and I'm gonna be like, no, you're really smart. You just make dumb mistakes, right? That's what happens in school, and that's why I'm here, to help you, right? Okay, so here's the dumb mistake. When I say that the element fluorine has 9 protons and a charge of -1, how many electrons does it have? You're going to say 8, because 9 minus 1 is 8, but that is wrong. Sadly, that is so wrong. Let's think about this here. We have electrons. What color did I do the electrons? Let's do them purple. Okay, so we have electrons. We have 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have protons. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the happy fluorine. This is the fluorine from the periodic table. Has 9 protons, 9 electrons. It's happy. It's neutral. But here now we have fluorine with a -1 charge. Now, if I take away a proton, does that make it -1? Well, we have equal. We have an extra negative charge. So yes, it's -1, but that's against the rules. Don't take away the protons. We cannot change the number of protons. So, okay, well, you guys said it's whatever. What did we just say over here? Oh, we said it was 8 because it's -1. So we're going to -1. Okay, what is this answer? If I take 1, 2, 3, 4, 5, 6, 7, 8, -8 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, what does that equal? It equals +1. Is that the charge that it says up here? No, it's negative. So you kind of have to do the opposite, and this is why. Let's go back to our neutral atom. So our neutral atom has equal number. In order to make it negative, it has to get negative things, right? It has to obtain those negative particles, which are the electrons. So in order to get -1, I must get more electrons. I don't know where I got this from, maybe from a chlorine, maybe from, I guess not a chlorine, it would be from like a metal like magnesium or sodium. I don't know. Wherever I got it, doesn't matter, but I got it from another element and now it's mine. And now I have a -1 charge because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So 10 negatives, plus 9 positives equals -1 overall. So you're looking at the difference. You have to remember that electrons are negative. So if I have a negative charge, I gained electrons. If I have a positive charge, I lost electrons. So let's add that to our definition up here. So a positive charge means we lost electrons, and a negative charge means we gained electrons. Let me space that out a little bit. Let's do one more example. I know I went fast. You can always pause these videos, go back, rewatch it, write down your questions. I know I go fast, but it's because you can, do whatever you want with it. You can go back and forth and all that good stuff. All right, let's say we have beryllium, Be. He is atomic number 4. And I don't care about his mass number right now. Let's say he has a charge of +2. And I want to know how many electrons does he have. Pause the video real quick, answer the question, and then replay it. All right, so hopefully you paused it and you have your answer. Now let's see if you were right. So I have beryllium.